The red supergiant star in the constellation Orion is suddenly shining 50 times brighter than usual. Excitement broke out among astronomers. Is this the supernova signal everyone has been waiting for? And is the red supergiant's explosion now imminent? Come along on a journey full of answers to these pressing questions and be surprised by what this star really is. This star is about to collapse. It is a bright red spot in the night sky, positioned prominently in the shoulder of Orion. It is the 10th brightest object in the night sky after the Moon, the planets Jupiter, Venus, and Mars, and some other stars. This star will soon disappear, that much is clear. The star, which has probably existed for billions of years, will outshine the whole galaxy in a final explosion and then collapse. All that will be left behind will be a neutron star or a black hole. The explosion will be an event of epic proportions, and at only about 650 light-years away, humans are ideally positioned to observe this cosmic spectacle up close. Still, we are far enough away to be out of the direct danger zone. When the stellar explosion occurs, it will bring an incredible spectacle of light across the galaxy. The first sign of the imminent collapse would be a sudden flood of neutrinos that would swamp the Earth and could be detected by observatories worldwide. Shortly thereafter, high-energy photons would escape from the debris cloud, and the star's final light would be up to 100,000 times brighter than we see it now. The actual explosion will exceed the brightness of the full moon at night, and even during the day, a bright light would be visible for a few seconds. After that, a supernova will shine brightly in the night sky for several weeks to months. The star will be among the brightest objects during this time and will be an unusual sight for humans. For astronomers, this will be an opportunity for detailed study, as such events only occur every few hundred or thousand years. The star is already showing suspicious signs. This red giant is so large that it would reach as far as Jupiter's orbit if placed in our solar system. Late in 2019, the aging star began exhibiting strange behavior. The red supergiant mysteriously began to dim. Even with the naked eye, observant people could see the star flicker. This kind of dimming had never been observed on the star before. Images of the star, taken in the optical spectrum with a very large telescope, initially still showed an approximate symmetry in luminosity. However, scientists then found the first signs of a large shock in the photospheric layers. Was this a signal that the star's final hour had dawned? The photosphere is the outer shell of the star that emits light into the cosmos, and this very edge had suddenly begun to expand enormously. It almost seemed as if the final scenario was about to begin. Briefly, the star swelled at a constant rate of about 8 kilometers per second. By mid-November 2019, the expansion stopped again, and astronomers held their breath. Would there be an explosion or not? At least not in 2019. The star held this inflated state for a while, and researchers took the opportunity to take a close look at the new situation. Images of the anomaly showed that a dark southern hemisphere had appeared on the star, for which there was no explanation. The only thing that was certain was that the star's face had changed extremely compared to an image taken in early 2019. Because the star's surface can be directly observed from Earth, it allows for particularly intense studies. Even amateur astronomers can track the stars, flickering with simple telescopes. Further, the scientists noted a dip in the star's surface temperature, it had dropped by about 80 Kelvin. Researchers were still trying to understand these strange events when it happened again, and the star's brightness suddenly decreased dramatically between January the 27th and February 13th, 2020. It reached a historic low. This condition also lasted a few weeks. Then the star began to brighten again and shrink back to its normal size. Scientists were baffled. It seemed as if the red supergiant had led them a bit by the nose. But what really happened? A gigantic mass ejection. It took weeks until all data showed a coherent picture. Then all the evidence pointed to the star having experienced an enormous surface mass ejection. Something similar happens on our Sun, but on a much smaller scale. We call this phenomenon a coronal mass ejection, CME. Because scientists had never observed the event on a supergiant, the phenomenon was given the name SMME, surface mass ejection. In these events, our Sun or any other ordinary star suddenly ejects a significant amount of its mass from its surface. But this star is no ordinary star. With it, everything happens in somewhat larger dimensions. It's a bit as if the aging star had a brute coughing fit. You can also imagine a superlative volcanic eruption. A large amount of material from inside the star moves upward, creating shock waves in the star's atmosphere. The material formed lots of molecules and dust that partially blocked our view of the star, making it appear darker. In the dimensions of this star, this event was, of course, a bit bigger. 400 billion times more mass reached the surface with the ejection than is the case with the biggest mass ejections of our Sun. The material was ejected with incredible speed. For researchers worldwide, this was the largest mass ejection they had ever seen on the surface of a star. The events and all the surface details were observed with Hubble, the old space telescope at that time. The James Webb Space Telescope had yet to be launched, but even Hubble was able to take impressive images of the event. For the star, it was not without consequences. The mass ejection had a strong impact. It lost a considerable amount of mass in one go. This proved that, in comparison, a dying star can lose further substantial mass from ejections like this, in addition to its annual mass loss from stellar wind. Scientists were not even aware until this point that stars in their final stages are also capable of such mass ejections. Since then, of course, it has been watched with excitement to see how the scenario continues to unfold. The star had a wound at the place of the ejection, and as it happens in old age, the giant star recovers only slowly from the injury. Since the ejection, the star's brightness pattern changed in an interesting way. It was known for a long time that the red giant pulsates every 400 days. Now this rate is every 200 days. Again, scientists draw the comparison with an old human being weakened by the ejection. In the dry, technical language of astronomers, the star is now formally a semi-regular variable star. What this exactly means is that it shows several cycles of increasing and decreasing brightness, which can be traced back to changes in its size and temperature. And within these patterns, it shows changes like the mass ejection and mysterious pulsation. In addition to its former 400-day pulsation rhythm, the star has another light show that occurs about every 5.6 years. The origin of these brightness changes is as yet unknown. Computer simulations showed that unusually hot gas flows from its interior may be responsible for the 5.6-year rhythm. These types of hot gas bubbles occasionally occur in the star's turbulent convective envelope, We might liken this phenomenon somewhat to a boiling pot of soup. Material is constantly moving and mixing and being swirled around. As this hot bubble rose and erupted from the surface, it caused the ejection of the star's material. The star will likely continue to change its pulsation in the future. The new short 200-day cycle will most likely give way within 5 to 10 years, and then the red star will flicker as in its usual 400-day pulse, or else it will explode still in an early stage. Scientists have to admit that they cannot know everything about a dying star. Much is still unknown, and events of this kind are so rare that even our best scientists currently have only fragmentary knowledge and can only guess. Based on the star's color, brightness, size, and estimated age, scientists suggest that it is still in an early stage of decay. It may be going through the helium to carbon fusion phase, in which the elements inside the star are changing. Instead of light gases, more and more oxygen, silicon, and eventually even iron are formed. The weight of the star increases as a result, and at the same time, it becomes more and more powerless. Eventually, the weight becomes so great that the core of the star collapses under its own weight and explodes. Since the star is 650 light-years away, any supernova event that occurs now would not be visible to us for 650 years because of the speed of light. So it could be that the star has already exploded and we will see the event soon. But then, the star would have already exploded 650 years ago, which was in 1373, a time when the plague and the 100 Years' War were raging in Europe. If the star explodes now or in 10 years, the light will be on its way to us for 650 years, and you and I will not be able to witness the event. Does a supernova bring bad luck? In the past, people on Earth observed supernovae several times. In 1604, the German astronomer Kepler witnessed a supernova, and around 1000 AD, Chinese astronomers saw a bright supernova in the constellation of Taurus. They had mistakenly assumed that the new glaring object in the sky must be a new star. At the same time, misfortunes, strange natural events, and disputes associated with the unusual cosmic event were occurring around the world. As far as renowned natural science is concerned, we are fortunately at a safe distance from any harmful effects. A space mission costing $560 million and almost 10 years of construction time was suddenly stuck in space after a brilliant launch. When the probe took to the skies on an Atlas V rocket on October 16th, many employees thought of a famous hit song. The joy was initially great because, with this probe, a new exceptional project had set off into a region of space where no other probe had gone before. The Trojan asteroids in the orbit of Jupiter, which were discovered only about 20 years ago. Just 3 days after the launch, a signal was received on Earth that no one wanted to hear. The probe had a serious problem, and the success of the whole mission was in the highest danger. From one second to the other, what had happened? There was immediate excitement, but as unbelievable as it sounds, the scientists, technicians, and computer specialists did not know at first what exactly had happened. Only after a comprehensive diagnosis did the project managers realize that the probe's power supply had not reached the required level. The probe's power was supposed to come from two 7.3-meter diameter solar panels. For safety and space reasons, the spacecraft had been designed to fly into space with its panels folded in and only then to spread its wings. But this very concept had apparently not worked out. The traction device of one panel had snagged for inexplicable reasons. The researchers could not see the problem. The probe is equipped with cameras, but they were not designed to focus on the spacecraft itself. An exciting detective work started to get to the bottom of the problem and solve it. A review of the panel's power production data provided further clues. Based on the amount of electricity generated, engineers saw that the second solar panel must be between 75% and 95% open. That was at least enough to keep the probe safely close to Earth and buy time to fix the problem. If the spacecraft had had no power at all, neither communications nor steering would have been possible. A nightmare for the technicians and engineers. But fortunately, this extreme case did not occur. It still remained a daunting and not without danger challenge for experts to repair a defective probe in Earth orbit when they couldn't even see what exactly was defective. Everyone now had to stick together and find a solution. The scientists first used a trick. The probe's thrusters were minimally activated to use the vibration patterns to determine how far open the module was and where exactly the problem lay. Thanks to highly sensitive sensors and precise computer diagnostics, it was possible to roughly pinpoint the location and degree of entanglement and fix it. The cable used to unfold the panel was sturdy but not indestructible. If under too much tension, it could break, and the entire panel would be lost. But how do you untie a knot that had formed thousands of kilometers away in space? To find a solution, scientists on Earth built a model version of the probe and spent weeks deliberating on what to do. Technicians had their hands full trying to solve the problem. Sending the probe off with a partially open panel would have been possible in terms of power supply, but without full opening, the second panel was too unstable to survive the vibrations and accelerations during flyby maneuvers intact. A compromise was reached. The probe would be launched, with the hope that normal vibrations and movement in flight might help loosen the snag. Additionally, researchers decided to periodically apply light tugs to the cable. This approach gradually increased the panel's opening, first to 353 degrees and finally to 357 degrees. The full opening was nearly reached, but the panel still couldn't be firmly anchored and secured. Nearly 10 months after launch in August, a critical decision had to be made: whether the spacecraft was ready for its first gravity maneuver. The probe's elliptical orbit was designed to bring it back near Earth, where it could use Earth's magnetic field to gain thrust and approach Jupiter without expending its own energy. It was determined that the panel's aperture was wide enough and the structure solid enough to survive acceleration forces of several kilometers per second. Still, the probe's flight continued to be a nail-biter. A year after its launch, the probe dipped back into Earth's gravitational field, accelerating as it approached within 350 kilometers of the surface, an inherently risky maneuver. Earth is already surrounded by 47,000 satellites and countless pieces of space debris. Just one errant satellite or piece of junk in the wrong place could have caused a catastrophic collision. Days before the probe's arrival, the sky was meticulously scanned for dangerous objects, allowing for a course change if necessary. This reconnaissance was conducted by a space monitoring agency established in 2019, specifically to catalog and track near-Earth objects. Even the International Space Station had previously adjusted its course multiple times to avoid debris. On October 16th, The probe briefly appeared over Western Australia, shining brighter and more radiant than the International Space Station. Visible to the naked eye, it soon entered Earth's shadow and disappeared into darkness for 20 minutes before reappearing over the western United States. The maneuver was successful. The probe remained unharmed and even used the flyby to calibrate its instruments and capture stunning images of Earth and the Moon. Currently, the probe continues its journey undeterred, despite its earlier issues. In December 2024, it will return once more to gain momentum from Earth's magnetic field before being directed toward an increasingly distant orbit, ultimately reaching its destination, the Trojan asteroids. Along the way, it has already provided unique new images of Earth and the Moon, discovered a new asteroid with its own small moon, and is set to observe a particularly special asteroid in April 2025. This asteroid, named after the scientist who discovered the famous hominid fossil Lucy in Ethiopia, holds symbolic significance. Just as the fossil vastly advanced our understanding of human evolution, the probe is expected to revolutionize our knowledge of asteroids. In 2027, the probe will complete its skywalk and reach the Trojan asteroids. These asteroids accompany Jupiter in two groups, one ahead of its orbit at a 60-degree angle and another trailing behind at the same angle. This arrangement, reminiscent of the Trojan War from Homer's Iliad, divides the asteroids into Greek and Trojan camps. The probe is designed to visit both groups, following an elaborate figure-8 trajectory 740 million kilometers from the Sun. The Trojan asteroids are of immense scientific interest. They are among the oldest objects in the solar system, relics of the primordial dust and debris from which the Sun and planets formed. Unlike planets and moons, they have undergone minimal change over billions of years, making them a fossil record of the solar system's early days. Few probes have had as many targets in their sights as this one. On November 1st, 2023, it delivered the first close-up images of a 700-meter asteroid. In April 2025, it will conduct a flyby of the aforementioned namesake asteroid. By August 2027, it will reach the first Trojan asteroid, a 64-kilometer-wide object, the largest in the Greek camp, which even has its own 1-kilometer satellite. Weeks later, it will pass within 415 kilometers of another Trojan, measuring just 5 kilometers. Between 2028 and 2033, it will visit several more Trojans. The probe has already provided a tantalizing preview of its targets. One Trojan briefly passed in front of a star, allowing scientists to determine its exact size, shape, and even the presence of a smaller companion, likely a moon. In 2020, a sensational report emerged. Scientists in Australia had allegedly picked up a unique signal that might have originated from an extraterrestrial civilization. The discovery was initially top secret, but the information leaked to journalists, leading to widespread speculation before researchers could verify the findings. The signal detected by the Parkes radio telescope was unusual, a narrow beam of radio waves at 982 megahertz, with a frequency shift typical of a moving planet. It appeared to come from the Proxima Centauri system, just 4.2 light-years away, where two exoplanets had already been discovered, one of which was considered a potential super-Earth in the habitable zone. If confirmed, such a signal, termed a technosignature, could indicate an advanced civilization, as natural cosmic phenomena rarely produce such patterns. However, scientists rigorously filter out terrestrial interference and known astrophysical sources before concluding a signal's origin. In this case, premature publicity complicated the investigation. The search for extraterrestrial intelligence, SETI, has been ongoing since 1960, analyzing radio waves from space for signs of artificial origin. Funded by institutions like NASA and private donors, SETI projects scan the cosmos for signals that stand out from natural background noise. While the Proxima Centauri signal was intriguing, further analysis is needed to determine whether it was a genuine techno-signature or an unexplained anomaly. The possibility of life in the Proxima Centauri system is tantalizing. Proxima Centauri b, a rocky planet in the habitable zone, could theoretically support liquid water and an atmosphere. A confirmed techno-signature from such a planet would be groundbreaking, evidence not just of life, but of an advanced civilization capable of transmitting detectable signals. However, until rigorous verification is complete, such claims remain speculative. The scientific process demands patience, ensuring that extraordinary claims are backed by irrefutable evidence. There had been hints of Proxima Centauri c's existence for a long time, with brief speculation that the larger object might be an Earth-like exoplanet. However, in 2019, it was confirmed that Proxima Centauri c was definitely a gas giant, orbiting well outside its star's habitable zone. This left the question, what or who could have caused the mysterious signal detected earlier? Shortly after the rushed publication of the signal in a major news outlet, researchers sought to clarify the findings in a more reputable scientific journal. They urged caution, admitting that much work remained to verify the signal's origin. Meanwhile, additional leaks fueled speculation. One researcher involved in the project was quoted calling it the most exciting signal we've found, emphasizing that it had passed more filters than any previous detection. However, a follow-up statement tempered expectations. While the signal had unusual properties that defied easy explanation, that didn't necessarily mean it was alien. The lead scientist of the program clarified that the signal was non-terrestrial in origin, but stressed that this didn't automatically imply an intelligent source. One of the scientists who detected the signal explained that no known natural phenomenon could compress electromagnetic energy into such a narrow frequency range, yet this was exactly what the signal, later named BLC-1, had done. However, he also acknowledged that BLC-1 could stem from an unknown astrophysical phenomenon. Despite over a century of radio astronomy, much about cosmic radio emissions remains mysterious. BLC-1 might have originated from an exotic plasma event rather than an alien civilization. By 2021, after more than a year of intense scrutiny, the scientific community reached a sobering conclusion. The researcher, who had initially been enthusiastic about the signal, publicly stated that BLC-1 closely resembled interference from human-made electronics. While the exact source was never pinpointed, the discovery was ultimately deemed terrestrial noise. Disappointment was widespread, but the search for extraterrestrial signals continues. Fast radio bursts, FRBs, are one of the most puzzling phenomena in astronomy. These brief, intense flashes of radio waves, lasting mere milliseconds, travel across millions of light-years, captivating scientists since their discovery in 2007. Detected only by high-powered radio telescopes, FRBs stand out against the cosmic background noise like sudden, unexplained screams in the void. Initially, their unnatural-seeming patterns led some to speculate about extraterrestrial origins. The signals were so unusual that early theories even considered deliberate transmissions. However, further research revealed that some FRBs matched the behavior of pulsars, rapidly spinning neutron stars. By analyzing dispersion, how different frequencies of the burst arrive at slightly different times, scientists could trace some FRBs back to distant galaxies. Yet not all FRBs fit neatly into known astrophysical categories. One burst, FRB 121102, repeated 1,652 times in 47 days, a pattern so bizarre that it reignited speculation about artificial origins. At its peak, it emitted 122 bursts per hour, a rhythm unlike anything seen in nature. Though later attributed to a magnetar, a highly magnetic neutron star, doubts lingered. Other FRBs have remained equally enigmatic. In 2019, Canadian researchers detected FRB 201912221US, a signal lasting 3 seconds, far longer than typical FRBs, with a repeating pulse every 0.2 seconds, resembling a heartbeat. Its source, billions of light years away, remains unidentified. Since the 1960s, SETI has spearheaded the hunt for alien signals. Funded by private donors and institutions, it uses radio telescopes to scan the cosmos